My force field design is shaping up. It can destroy large objects, but it's still vulnerable to small caliber weapons. I need to add a second layer to my force field. Something super tough and tightly knit to stop even the smallest projectiles. Perhaps I can use some atomic engineering. On this tiny silicon wafer here at MIT, I'm growing the world's strongest synthetic material, carbon nanotubes. They are extremely tiny. They're only 50 atoms across. That's 20,000 times smaller than the thickness of a human hair. And yet they are incredibly strong. This fabric made from nanotubes weighs less than a cotton sheet, but is as strong as steel. Brian Wardle is at the forefront of nanotechnology research.
This is a sheet of carbon nanotubes, a very, very large sheet of carbon nanotubes.
10 years ago, something like this was considered impossible, right?
Absolutely.
And here it is.
And here it is.
This nanosheet is part of a classified military project. It's at the cutting edge of technology. So Professor Wardle can't tell us what it might be used for. All I can tell you is that it's made by randomly overlapping billions of nanotubes, each just 1/30th of an inch long. But Professor Wardle can reveal the ingredients that make the nanotubes super strong.
You need carbon, temperature, and seed particles. The carbon comes into the growth chamber in the form of a gas through these hoses here. The gas is supplied by large pressurized cylinders. The temperature is supplied in the oven here through resistive heating, like a toaster. And the seed particles are contained on this wafer.
Carbon is renowned for its strength. It's what makes diamonds the hardest mineral in nature. Inside the oven, carbon atoms from the gas attach to the silicon wafer, and then they form hexagonal bonds with each other. This is the secret of nanotube strength. Hexagonal carbon bonds are some of the toughest because each carbon atom joins to 3 of its neighbors. The carbon nanotubes have been baking for a while. Is it time to take them out of the oven?
Now, let's see what we have. Now, we've grown billions of nanotubes on this wafer. We've grown into a forest.
I see. Yeah, look at that. You see all these black structures, sort of like skyscrapers, coming out of that silicon wafer consisting of carbon atoms.
Looks a bit like fuzz, but that's the forest that is grown from the catalyst seeds.
And wait, it's spelling out something. It's MIT.
A little joke from my group.
Today, scientists can mass-produce nanotubes around 1/30th of an inch. But within decades, they'll be manufacturing nanotubes hundreds of feet long. And when that happens, woven nanotubes will be an ideal raw material for my force field. A nanotube force field is like a golf net. Any solid projectile hitting the net will be stopped dead in its tracks. The net is so strong that it will absorb any impact and not tear. Even if the projectile were explosive, the net will still hold. Nanotube sheets strong and large enough to protect a spaceship are perhaps only decades in the future. But once scientists crack the secret of increasing their length, they could add another protective layer to my force field. I can encase the spacecraft's exterior in a transparent nanotube cage. If the spaceship is attacked with small caliber cannon fire, the cage is tight enough to stop the threat. But I haven't thought this all the way through. The nanotubes cover my weapon's ports. I can't fire back. But there is a way out of the problem. Using artificial intelligence, you can create a zipper. Computer-controlled, they'd be installed over each weapon's port. They'd instinctively open when I fired the ship's weapons, but close immediately afterwards to maintain protection. my design is coming together. But as every sci-fi fan knows, projectiles and space debris are not all a force field will face.
Well, if a laser or anything actually hits the force field, it should repel it.
Good force field should be able to protect you against space debris, lasers.
It protects the ship from things like lasers and asteroids.
Lasers are the ultimate sci-fi weapon. In the movies, they can destroy whole planets. I've got to find some way of blocking lasers if I expect my ship to survive a hostile encounter in deep space. Get more online at sciencechannel.com/sci-fi science.